So today's talk, I know this is not the same headline as in the program, so I changed it a bit because on the program I think it ends with the word prof. Yeah, so prof. Yeah, basically this is what I'm going to talk about. It's sharing health information through APIs and how we will make that work in Norway for the health sector. All right, so I'm Steinar. Nice to meet you. I'm very glad you guys showed up to this talk. I'm a programmer, or has-been programmer, has turned soft, so I'm more or less working as an architect or, I don't know, glorified secretary or whatever you call it. So I mainly work on digital identity, which in my case means authentication and authorization. I focus on Oauth and OpenID Connect. And I've been working on, I don't know if this is even a word, but enterprise architecture. That's it's a term. I don't know if a lot of people uses it, but it's sort of become like a term that some people use at the time. Yeah, so I've been working for the health sector in Norway for 7 years now, and that's a picture of me. It's how I feel on the inside. Today, I think maybe it reflects my outside as well, perhaps. So today, I'm hoping to maybe endow on you some knowledge that we've achieved or been able to learn. I want to talk about trust, what it is. I want to talk a little bit about the challenges of sharing health information within the health sector in Norway. I want to talk about the building blocks of a trust framework. Now we're getting fluffy. And I want to give you an intro to the security analysis of the authentication protocols, especially Oauth. And last, I'd like to talk about FAPI 2.0, which is a security profile for OpenID Connect and Oauth. So after this session, all of you will have become trust framework superheroes and FAPI 2.0 experts. That's a guarantee. All right, so what is trust? Well, trusting something is a decision. I guess, having to make a decision means that there is some uncertainty, because if you have no uncertainty, then it won't be a decision. So it's a decision which is based upon facts and experiences that you have had with the party you want to trust. So this picture of the dog here is just, brings up emotions. I have a cat. I've treated it very, very, very nicely for its entire life. It still thinks I'm going to cut its tail and ears off. So whenever I come, it generally just runs away. So it doesn't trust me at all. So, all right, I think this is my favorite quote when it comes to trust. So the best way to find out if you can trust someone is to trust them. And I think this is right. That's basically the only way to find out if you can trust someone. And when we're talking about digital identity or security, we have some new sort of concepts or what's it called, catchphrases or acronyms, etc. One of them is zero trust, which I think is a misdenomination. I think there is never zero trust. There's always trust when you are dealing with the digital world. All right, so as I said, I work for the health sector in Norway. In Norway, healthcare is free. We have a lot of different actors. We have the specialist healthcare, the health regions where the hospitals and the specialists work. We have the primary healthcare, which is municipalities, etc. And we have a quite good national sort of service layer, And for the digital part of the health service, we have a lot of really good services. We have prescription service, we have a centralized EHR system, and we have loads of other stuff. So, when we talk about sharing health information, we generally tend to sort of dive into the details of the technical aspects, but this is the main goal. I mean, giving the patient the right treatment at the right time, that's the end goal. And all we do is, everything we do is to make this possible. So, I mean, all you guys are technologists. You'd probably say, well, how hard can that be? Well, quite hard. First of all, we have a system landscape which is, I don't know, kind of scary. Loads of different systems. These systems really don't talk to each other much. Some of them are very old. We have variants within the technical architecture. We have app service, we have web-based systems, we have desktop systems, we have mobile systems, we have old systems, new systems, platforms, cloud systems, on-premise systems, anything, multi-tenant. So this, makes it a little bit difficult, and that's been one of the challenges working on sort of sharing health information on a general basis, not only through APIs, but generally. And the other thing is, it's a sort of treacherous road. We have a lot of requirements. So the patient security is probably the most important one. I mean, being able to treat the patient without him dying, that's, it's a requirement, I guess. We have the requirements for interoperability, which means we have to be able to interoperate on several different levels. I mean, we have semantical interoperability, technical interoperability, legal interoperability, etc. It's difficult. We have legislation. We have loads of laws. I mean, we have GDPR, we have the health legislation, we have sort of bordering laws, like IDAS, the EID regulation. And this is, with their requirements, it, sort of builds complexity. And when you look at that combined, it starts getting quite difficult. And then you have the cybersecurity part of it, because health is a popular target. It's not only a popular target for the regular attacker. I mean, the script kiddies or the random people attacking different parts of the health sector. It's also attractive for like government-run agencies, because it's interesting to get health information. It's powerful and it can be used in many different contexts. So, if you're a politician, for instance, perhaps it could be useful if you're in some sort of, I don't know, discussion with another country about fishing rights, for instance, to know that, you've been treated for mental sickness or something like that. It's valuable. So this is makes it kind of complex and kind of difficult. And on top of that, we're sort of missing some basic and important pieces to the puzzle. We're trying to digitalize Norway, but we don't have the necessary tools. So this makes it even more difficult. I won't go into the details here. I've listed up some things, but loads of different things that are lacking. But from the digital identity part of the problem, we don't even have a register that tells us that this is a organization that treats patients. I mean, we can sort of figure it out by looking at the NACE code or some Næringsskole or similar. Yeah, but it's kind of guesswork. We also have very little concrete knowledge about what sort of comprises a good enough level of assurance, for instance. Yeah, all of this is this makes it difficult. So, and perhaps, you know, this sort of creates a problem. It's a problem that has to do with trust between the actors. There is no low, you know, they don't trust each other. We don't trust them. They don't trust us. So how can we fix that? Well, I have a solution. The trust framework. Did you feel that? Exciting, yeah? So this is, I don't know, this is kind of fuzzy, but I'll try to explain what it means. I'm not sure if it's a good explanation, but I usually, when I talk about this, I usually describe trust in using the same concepts as a European interoperability framework, so EIF. And in that framework, we try to separate the different sort of dimensions to the interoperability problem. And you know, I tried to do the same with the trust issue. So as you see here, we have four dimensions. And the legal dimension, it's about laws and regulations and, you know, stuff like that. The organizational dimension is about contracts and agreements, you know, creating the trust on an organizational level. The semantical thing is about understanding each other. I mean, when I say that, well, I have the legal basis to access this information, then we need a way to express that in a way that everyone understands. And then we have the technical dimension, which is about standards, mechanisms, how to make sure that this is secure enough, et cetera, et cetera. So there's an order to this as well. I think this is kind of important. This is one of the basic learnings we've had during these years we've been working on the topic. Things need to sort of be put in place in a sequence. So the legal dimension is sort of the underlying thing. It needs to be in place. If you don't have that, there's really not much to do in the technical dimension. And it's the same for the other ones. I mean, you need the basic stuff before you go ahead. Which is why we talk about the hierarchy of trust, which is also sort of like a homemade thing based on Maslow's behovshierarchy. Sort of illustrates this point. So now, when we sort of put this together, we can talk about the trust framework, or the ecosystem that this will sort of function in. And I've just put some examples up here, but we have necessary registers, we have the laws, we have interpretation of laws, agreements, code of conducts, technical requirements, common language, trust services, tools, etc. And all of these things work together in an ecosystem, which is closed. And in Norway, we have the health network, which is a voluntary member-based ecosystem that provides loads of services. But this sort of draws the boundaries of our trust framework within this ecosystem. Yeah, so and I'm wondering, yeah, sorry. I think perhaps my slides got messed up here, but okay. So my talk is supposed to be about FAPI, and FAPI is Oauth and OIDC security profile. So I think it's kind of useful for you guys to know about. Many of you perhaps know it already, but some years ago, these scientists created some new methods of analyzing authentication protocols using formal analysis methods. So basically what they do is they express a model, and then they run sort of scenarios on that model by punching in the protocols. And this is all built on the web stack, so you have everything in place before you run the scenarios. Yeah, so these new methods, they were developed at the University of Stuttgart and Bochum, I don't know how that is pronounced. And the analysis, as it turned out, quickly, they quickly discovered some weaknesses, unknown weaknesses in the protocols. And these findings were presented to IETF, and the IETF said, "What the hell? Is this true?" And then they started working on mitigations, trying to sort of mend the protocol by extending it with new extensions. After that, the same researchers analyzed the FAPI profile, which is it's a specialization. I mean, it basically selects for you. So these researchers, they analyzed the FAPI 1.0 profile, which is heavily used by open banking, for instance. And they found weaknesses there as well. So all of these results ended up in a new best current practices document, which is, it's not an RFC on IETF, but it's a document that sort of outlines the way to do things. And this document, which is called the Best Security Practices, is a very good description of the weaknesses of the protocols. And also, as it turned out, they were able to develop an attacker model, which is really interesting because it describes the attacker in a way that allows you to sort of do risk analysis and new approach. So Daniel Fett, which is a researcher that is an expert on Oauth, he has worked a lot on this attacker model. I'll try to sum it up for you here. My time is it 17? No, 12:20. 12. Oh, so I have a lot of time. Oh, great. Yeah. Yeah. Okay. So the attacker model is a generic description. I mean, the idea is to model the way the attacker thinks, and then when you can model the way the attacker thinks, you can also look at the possible tools he has. And then you can start sort of mapping these weaknesses to mitigations. And then you can use that again when you sort of do your risk analysis of your systems. So the attackers that the attacker model for Oauth describes, there are two main types. It's the web attacker, and it's the network attacker. The web attacker is like a user. He can do anything that a user can do. He can control responses, requests. He can, do XSS attacks. He can do, stuff like that. Take control of your browser, replay tokens, etc. What the model says is that the web attacker cannot break cryptography. So that's like a premise. We say that, okay, it becomes difficult if cryptography gets broken. I mean, you're basically fucked. So let's just say that cryptography is in place. He can also not intercept messages sent to other parties. And here's one of the big differences between the network attacker and the web attacker. Because the web attacker cannot intercept messages, while the network attacker can. He can do anything the web attacker can. He can control messages. He has access to the network infrastructure. He can intercept messages that are not sent to him. And he can read and modify unencrypted messages. This is the NSA or the GRU or I don't know, all their names. Yeah, but it's state-sponsored hackers. They have money, they have resources, they have knowledge. So still the premise is network attacker cannot break cryptography either. And that's sort of the premise that we have to base everything on as we talked about trust, you have to put some trust somewhere. So cryptography is considered to be safe. So all this analysis, the attacker model, the security formal security methods, it's quite funny because I mean, what we traditionally have done as security analysts is to sit and use your mind power and, walk through scenarios and, you do all, tedious hard work and you go home tired, crying, everything, and then it's terrible. And then this formal methods sort of pops out of nowhere and suddenly you can have like a structured approach and it turns out is really effective. So I'll go into the details a little bit more here, but Oauth has some known attacks. So Oauth is just a framework, and the framework in its sort of plain vanilla form, it's not, you can make some pretty bad choices there if you want. But the main categories of the attacks is listed here. I guess these are the sort of main categories when we talk about the protection of the protocol itself. We sort of focus in on the protocols. We don't think about all the other stuff, XSS attacks, etc. How do you protect against open redirects or whatever? Yeah. So when they started looking at this, they put up a sort of description of different attacks and how they could be employed. And this list is not full. There are more things, but this is like the general sort of overview of the attacks. And I mean, for health, we are really afraid of some of these things. I mean, token replay that's one of the things about APIs is that, how on earth are you going to know that the client is who he says he is if he's able to steal tokens? It's like a $100 bill. I mean, if I give one of you guys the bill, then no one knows it's mine. So you can spend it on whatever, and money is mine, but you can use it. Same with bearer tokens. It's like one of the fundamental problems of Oauth, I think. Or basically using JOTs, yeah. So the question might be, you're using Oauth to share health information when you know the protocol is sort of broken? Really? Is that a good choice when we know of all of these weaknesses? And the answer is, well, we think so, because this work that has been done on security analysis is not only lets us know what the problems are, but they also lets us know how to protect against them. And when those problems or these security issues are found, then if there isn't a solution for it, then the right people can find a solution for it. So it's a very good game, I think. So this is a list where, if you see on the right side here, you have the measures, the measures, the protection measures you do for the different attacks. Some of them are brand new mechanisms like pushed authorization requests, and JAR is another specification that's probably not well known, but some of these things have existed for a long time. It's just that people need to start using them to protect against these security issues. So I'm gonna jump over to FAPI then, because this is sort of the next sort of logical step. It's FAPI. So, no, it wasn't the next step. Yes, it was the next step, yes. So what is FAPI? Well, basically it was started by the PSD2 regulative. I'm not sure, regulation it's called in English, yeah, thank you. and where all the countries in EU were forced to share some data. They, the customers, the bank customers, had to be able to access their data easily, and they should be able to do payments, et cetera, et cetera. And through that directive, regulation, they saw a need to protect the APIs, and they saw that the use of Oauth would probably be a good fit, considering there being a user, and the user had to delegate access to the clients, etc. So, user consent was a big thing. But Oauth was considered to be unsecure. So they said, okay, if we're going for Oauth, we need to do some profiling. We need to say that, okay, if you're going to use it, you have to use it this way, and this way, and this way. So they established a working group in OpenID Connect Foundation, and they started hammering on the different parts of the protocols, and they soon saw that, hey, we're lacking some stuff here. So they also started developing new specifications, not only security things, but also functional things, just to make the open banking system, ecosystem work. So as it turned out, open banking in the UK sort of was ahead of the curve. They did some really, really good work on their API descriptions. And they were very important in building the specifications, the new specifications that were tied to FAPI. And it was basically a big success. I mean, most banks use it today in Europe, a lot of them anyway. If you talk to someone who implements it, they might say something else. But I mean, from a little bit distance, it looks like it's been very good. Yeah, so basically, in FAPI, the right decisions have already been made. That's sort of the sum up. If you do it this way, yeah, you'll be fine. You've covered all the major problems in the protocols. So when we look at FAPI in our sort of trust framework context, it's a little bit interesting because as we started working on it, me and my colleagues that are sitting here, we quickly saw that, hey, this is actually giving us some tools that we need as well. It's for health information, not financial information. We saw that FAPI was, had some really clear strengths. It's, every FAPI system can do a conformance test to prove that it's worthy of being called a FAPI client, which is really, really, really good. And it sort of increases the trust between actors because we know that we all do it the same way and it's done in a secure way. And that sort of builds trust. And then we saw that, hey, well, this is actually quite a good way to express some understandable information. Yeah, we can do, we can do stuff in the tokens here. We can say, okay, we have the user, but where does the user work? What's legitimate interest? Other types of information. Is this guy a health personnel, etc. Yeah. So it's these things sort of work together in a magical way when we look at it, because now the client, through these new specifications, is able to pass information to the authorization server, which is a really, really potent thing if you think about it, because Helside, the product that we built, the OpenID Connect provider, national, establishes a trust relationship to the clients on behalf of APIs and systems. And if we sort of build upon that trust relationship, yeah, then we can say that this information that they pass to us, well, it's quite credible actually. We can start, believing that this information has some truth value to it because it is, likely that this is the client that we think it is. But also, another thing that we saw was that we can enforce requirements and we can enforce some of these regulations and laws, etc. I mean, we can do on an organizational level and do checking. We can say that, well, we've got a client here. We know that this client, he's it's a system that runs in this hospital. But we don't know if that hospital actually does things the way we want it to do. So let's not accept that request. Or we've heard that that hospital has been compromised. They've been attacked, or they have whatever. Yeah, we can say, sorry, you can't get access to the national systems. You can't get access to the APIs that are national. Also, it caters for the legal dimension by sort of laying the grounds or catering for accountability. And accountability is, the Norwegian word is notoritet. It's about being certain that someone has done an action. So, I mean, we had a discussion about this yesterday. The technical word we often use as developers is non-repudiation, which is a key usage, basically. It's connected to some certificate or PKI thing. Well, that's not it's not the same. I mean, in law, everything is fuzzy. So when we talk about accountability, it's basically being able to prove, good enough proof that some person has done something or some system has done something. So it turns out that a lot of this terminology that we use, we use it every day. It is as precise as we wanted it to be, and it sometimes works against us. Yeah. So what has happened now is that we've talked to OpenID Foundation. We said, hey, why do you have a profile that's tailored for the financial and bank industry? We want it as well. And then some other people said, yeah, we want it as well. Why do you guys call it financial? It's, this is a general purpose thing. Why? And then OpenID Connect Foundation said that, yeah, you're right. Let's not call it financial APIs anymore. Let's call it fortified APIs. So let's keep the name FAPI, the brand name. Yeah, so basically we have now a new profile. It's based on experience on the FAPI 1 profile, which was kind of difficult in some parts. They had some concepts, one concept which is called lodging intent. That is sort of like the precursor to rich authorization requests, in where a client can indicate something about some details about his request or his grant. I'm asking for permission to do this, and here we have some extra information that describes that. So it's a natural progression. I mean, this is based on experience and based on the need for simplification. It also has stronger security measures. It's based on the attacker model and the security analysis that these professional scientists have done. And also, trying to make it like a general purpose profile meant that they had to sort of tear some things out of the profile and say that, okay, let's put this specification and this part of the profile here. And it can accompany the profile. You have something called SIBA, for instance, which is could be used for other things, but mainly used for banking or financial services. Yeah, so I guess I mentioned this before, but this is an important point. All this stuff, what it does, it secures the protocol itself. It's nothing else. I mean, all we care about is that we can be pretty damn sure that the token request and the token response comes from the right actor and ends up in the correct hands. That's the protocol. That's what we talk about. So the building blocks. Well, it's pretty clear. This is Oauth 2.0 and OAuth 2.1 coming now. That will be sort of the basis for the next OAuth specification. There are several extensions. There are general technical requirements, general security requirements, and there is this conformity testing thing, which is important to the FAPI framework. So the conformity testing basically is a service that's run by OpenID Connect Foundation, where you can prove that your authorization server is doing things the correct way, and you can also prove that your relying party, I mean the client in OAuth terms, but the relying party, which asks for user authentication, is doing things on the right way according to FAPI. Another very important piece of the puzzle for us is something called the identity assurance specification. It's a way to express a trust framework, so it hasn't anything to do with FAPI directly, but it's an important piece of the puzzle. This slide actually was going to come later, so I think I missed a little bit here. Okay, so these are some of the most important pieces. I've tried to sort of, make some boxes with some words in it. I don't know if it makes any sense for you, but these are important mechanisms and, pieces of specifications that helps make the use of OAuth a lot better. So you have the PKCE, the PKCE, proof key for code exchange. That's the mechanism that you basically should never use OAuth without using PKCE, in my opinion. We have strong client authentication, meaning that you basically don't use shared secrets. Always use some sort of crypto. We have a quite substantial restriction in the allowed grant types. I mean, implicit flow, it's no-go. Never use implicit flow. The resource grant type, no-go. So yeah, basically, authorization code flow is the only flow that you should use when you're using FAPI. Pushed authorization request is also a way to increase the security of the request to the authorization server, because right now it's a GET. You do a GET towards the server, and then all the parameters are visible in the request. It's basically a little bit difficult to secure it in a good way. So pushed authorization request does something about that. It removes the need for sending parameters through the request itself, and then instead it returns an identifier, which you can use again later to sort of provide enough information about the request. FAPI also says something about sender constraining. It says that it's a requirement, or the client must be able to do sender constraining of tokens, which basically means connecting. So I was actually going to do a talk together with Dominic Beyer on this today. Bit sorry that he became ill, but I think that was the topic that we're going to talk about there. So it's a big topic in itself. I really think it's interesting, should be interesting for everyone. But anyway, it's basically about tying the token to a client. So when the API or the resource server receives the token, it's able to control or to check that the client that requests is the same client that receives the token from the authorization server. It's cryptographically bound. Also, we have something called rich authorization requests. We're using that all the time, actually, in the health sector in Norway. That's a way to convey information about the grant, as I said before. FAPI also says something about or mandating the use of HTTPS, and it says something about crypto systems, which crypto systems you're allowed to use. It's double crypto systems, yeah. Okay, now comes some not so colorful slides. I hope that's acceptable for you. So these are just some examples. I'm not sure if I have, yeah, I have a good time. So these are requirements connected to the FAPI profile. That's sort of general. It talks about, you know, how do you do client secrets? How do you do signing? How do you do, yeah. Quite explicit on the allowed algorithms, and the non-choice for the JOT is explicitly forbidden, which is, I mean, who on earth could have thought about having that as an option? You're doing a JSON web token, and then you could say, nah, well, no, I have none as a signature method. Probably not a good choice. Also, we have some quite strict requirements for the authorization service. We have, as I mentioned earlier, we have tightened the allowed grants. You're not allowed to use implicit flow. You must reject authorizations that are sent without pushed authorization requests. You must support the RAR specification if you are to convey information from the client to the authorization server. You should only issue sender-constrained access tokens using mutual TLS or DPoP, which, so if you read this again, it's not a requirement that you use sender constraining, but if you use sender constraining, then you need to use mutual TLS or DPoP. So also, requires support for strong client authentication using mutual TLS. And that's also quite interesting, actually, because mutual TLS is a specification that sort of piggybacks on the TLS connection. So if you have mutual TLS already set up, then it's really easy to get sender constraining. And if you go one step further, you can say that, okay, I can start creating and passing out client certificates to authenticate the client as well. So that protocol or that specification actually describes how to do both. You can authenticate the client and you can sender constrain using the same mechanism, which is pretty awesome. Some drawbacks though, but I'm not going into that. So more requirements. You have to use PXE. You have to use the redirect URI parameter for security reasons. You have to return an issuer parameter in the authorization. There's also concrete measures for concrete attacks, mix-up attacks, for instance, rogue authorization server. I mean, loads of different scenarios where these are really effective measures. So you're not allowed to use HTTP. You have to use HTTPS. You're not allowed to reuse authorization codes. Good idea, perhaps. You're not allowed to use the 307 status in redirecting. That opens to some attacks. And for client side, I mean, that's sort of like a reflection of the requirements for the authorization server. But it's interesting still. So on the client side, you have to do all the things that the authorization server says you have to do. And for the resource servers, yeah, there are some requirements as well. This is, I mean, basically perhaps good advice in some form, but sender constraining is a thing that is made for the API basically. So it's a really good idea to use. All right. So this is perhaps where we were. This is where we're at now. Do you feel like Trust Framework superheroes or? Me neither. And I've been working with it for a long time. But I hope it's interesting for you as well, because it's in health we have our problems, but I think a lot of these problems are the same for other sectors and other sort of domains. So If any one of you wants to talk about trust frameworks and Oauth and FAPI and stuff like that at a later point, just go ahead. This is my favorite topic. Yeah. You can read if you want to, but you don't have to. Anyone has any questions? That I can't answer or can answer or. No one? Yeah.
Is it fair to say that FAPI is like a selection of the best practices that are already available in Oauth and corresponding specs?
Yeah.
Yeah. Correct, right?
I'd say so. Yeah.
It's like the super selection of best practices.
Yes, and it's very precise, and I think that's probably the strength of FAPI is that it's so precise when it comes to the things it prevents. So it's so it's a reason for every sort of choice they've done in the profile. So it's and that's a good thing because it's quite difficult sometimes to know why you do. I mean, I do this, and why do you do this? Well, I don't know. So that's the thing I think I really like about FAPI is that you can sort of draw the lines from attacks and known attacks and weaknesses, etc., to concrete recommendations and mechanisms. Yep.
Let me just give the mic.
Yeah.
It's fitness time for the.
Yeah.
Yeah.
For the online audience, just the mic so they can hear.
It's gonna go around to the mic.
Oh yeah, sure, good, yeah, cool.
Yeah. Is there any reason for not using FAPI?
Yeah. Yeah, it's so basically complexity. It's I mean, and also I think, when you look at the description I went through of our needs in the health sector, we have so many layers that needs to be satisfied, and also I think it's important to remember that these are high risk scenarios. My personal opinion is that I think every single OAuth client in the world should use sender constraining tokens. My personal opinion. I think, if you're doing interactive sessions, user logins, well, you should always use authorization code flow. You could use like the hybrid flow, which is an alternative, but it's more complex. So authorization code flow. A lot of these things are sort of sound and reasonable, but as I said, it requires some complexity, and that complexity is often handled by the developers, developing the client, for instance. And I guess it's a trade-off, but at the same time, I think one of the things that I think is really lacking within the OAuth and OIDC community are good client libraries. It's difficult to find, and all of them are sort of lagging. So there are a few client libraries that do all this stuff good, do it in a good way, but loads of them you have to tweak. So that's our experience. Is the complexity sort of? It's a bit too bad.
It's layered complexity as well, right?
Yeah, it is.
Developers struggle with understanding the basics of OAuth and then adding all of this stuff on top, like keys for this and keys for that.
Yes. Yeah.
Adds up and
And then it's so easy to introduce errors, right? You introduce new security issues because you have all those layers. So it's and for all of you who have tried using the crypto API in browsers, for instance, you do have decent support for it, but it's as we discussed, it's very easy to make mistakes. There are loads of pitfalls, and the same with just the basic stuff of doing, signing, encryption, all that stuff is you need to get it right. It's and it's not for everyone. I mean, a lot of the developers we talk to really don't, they don't care. I just want to, I just want to make my stuff work. Why do I have to do this authentication security stuff? I mean, that's something we hear quite a lot, and it's scary, but that's the real world. So what we do, we do code reviews of every single client that uses our federation gateway. Every single client, every single relying party, they have to go through these two guys that sit and look at the code. And it's the results they look at can sometimes be quite scary. Sometimes really, really good. Other times really scary. So, yeah. Should we sing a song together? Oh, you have a question? Yeah.
You kind of answered it, but I'm still going to ask. You said I was so. I wasn't so. Oh, okay. Yeah. No, you kind of answered the question just now, but I still want to ask it. Is there some premium place for developers, client developers? I'm thinking about to kind of go and get the best information for developing against this.
Yeah. There, there are some, so I mean, it depends on the programming system. I mean, if you're programming .NET, you have, your options, your set of tools, and if I'm sort of answering a question now, I'm not sure.
Yeah, because I like this FAPI framework, particularly because you said you can backtrace to why.
Yeah.
That
Yes.
I really liked, and I would like that there was some nice tied in with how I translate that into my coding.
Yes. Yeah, I totally agree. I think, this is one of the things that we've been working on. This is information. I mean, basically just getting the information out there. I mean, it exists in specification form. You have like a BCP documents from ITF, and they sort of outline all this stuff in great detail. And but when it comes to the choices you make as a developer, when you code it, it's really a lot of it boils down to the tools you have available, and the abstraction levels of the client libraries it varies a lot. The support for the different mechanisms varies a lot, so you quite often have to extend it. But I mean, so basically learning about it, for me, I've learned a lot just following, looking at, listening to podcasts, looking at videos, reading stuff like Philippe here. He's a fantastic teacher when it comes to all this stuff. Many others as well. And I think what's good is that I think the sort of development of the security surrounding these specifications are getting kind of stable or more stable. So there aren't that many changes. There aren't many new problems that have been found. So, which makes it a little bit more easier to follow. So yeah, a lot of the stuff is sort of reaching the done status. So let's hope that it's a better, we're able to get better client libraries in a while. That's, if someone wants to make one, I think that's a good idea. It's an opportunity for an open source project, perhaps. Yeah. Also, that's another thing. Actually, programming it is a good idea. It's a great learning experience. Actually doing a client. You probably won't have to sort of put it in production or sell it, but I mean, the protocols are quite easy. So when you start looking at the flows, so yeah. I'm just trying to sell the idea of great client libraries. No, but it's an opportunity, but it's for specially interested people, I'd say. Yeah.
You mentioned try to build a client, and then you also mentioned conformity.
Yeah.
Are you doing drugs on stage? The conformity, is that automated? If I build a client, can I run that conformity test suite against it to see if I did a good job or if I messed it up?
You sure can, yeah.
Awesome. So that's a good learning pattern, right?
It's very good learning path. It's tedious because there are loads of tests. So, but it's a very good learning experience. And also, I mean, if you do get it, I mean, these commercial products, the OpenID Connect products, are all certified, like Microsoft, Okta, Auth0, Duende, you know, and they put a lot of effort into doing these conformity tests because it's a quality stamp from OpenID Connect Foundation. Sort of guarantees that these products are, you know, capable of doing what they say they do. So. No trolling here. No trolling allowed.
Love listening to Steinar talk.
Yeah.
Now, since you have a few more minutes, what's next? You talk about FAPI 2.0, you talk about OpenID Connect.
Yeah.
What's next? What's coming up?
Great question. Yeah. Yeah, it's a very, very good question. So, I mean, we're talking about Oauth is 10 years now. It's even It's even older, I think.
2012.
It is 2012, the 2.0, yeah. So, yeah, we have a new version of Oauth coming up. It's called Oauth 2.1. It's sort of a specification that tries to consolidate all the different sort of specifications that are out there. And it says that, okay, well, we've learned a little bit, you know, during these years, so it's probably a good idea to sort of remove all the things that are, you know, bad patterns. And we remove those and we put in some new specifications that are good patterns. And then we get Oauth 2.1. And then there's also another working group in the IETF that is working on a brand new protocol called GNAP. And GNAP might become Oauth 3. And that's really a quite interesting specification because it sort of takes it's also very, very interesting that this guy, Justin Richer, who he's been writing this stuff together with some other people, he actually backported, or he pulled out some of the concepts in his sort of GNAP model, and he put them into IETF Oauth 2.0. So PAR, pushed authorization requests, RAR, JAR, all of these three-letter acronyms, all those specifications actually come from the work that has been done with GNAP, which is kind of cool, I think. But I think the work on GNAP is something to follow. I mean, you know, just to be aware that there is something happening, which is probably a better fit for a lot of the scenarios we see in like the workplace environments, and then, you know, so the internet scenario, which Oauth was made for, that's one scenario. We have a lot of other scenarios that Oauth isn't like a perfect match for. So GNAP will probably close some of those gaps. Yep. No more questions?
Promote the Oauth security workshop.
Yo, yes! That's such a very, very good, thank you, Flip. So if you felt the warm feeling of joy when we were talking about this Oauth thing, you should come to Trondheim in May for the Oauth security workshop. A lot of really, really skilled people will be there. There are a lot of presentations and talks, and it's a different kind of, it's not a conference, it's a workshop, so it's a discussion-based forum. So heavy interruptions during talks, for instance. So everyone that's interested should come. We don't have a lot of tickets left, so yeah.
When is this?
In May, 4th to 6th of May in Trondheim. Yeah. All right. Well then, I'll let you guys listen to some interesting stuff instead of this shit. I'm kidding. I really love this. It's I think my job is really rewarding. So yeah, thank you very much for listening, and thank you for coming.